Hello friends, I welcome you to my YouTube channel Mac PM. So in this video we will solve a numerical problem which is based on eccentrically loaded welded joints. Okay, so let's read the problem and note down important parameters. A rectangular cross section bar is welded to a support by means of fillet welded as shown in figure. Fillet welding is like this. Okay, triangular. Determine the size of the welds if, so we have to find S. Okay, size of the weld if the permissible shear stress in the weld is 75 megapascal. So tau max is 75 megapascal, which is equal to 75 into 10 to the power 6 pascal. 1 pascal is equal to 1 Newton per meter square. So it is 75 into 10 to the power 6 Newton per meter square. So it will be equal to 75 into 10 to the power 6 Newton per 10 to the power 3 square, because 1 meter is equal to 10 to the power 3 or 1000. 75 into 10 to the power 6 divided by 10 to the power 6 square. So it is tau max is equal to 75 Newton per square. Okay, now you can see load is given as P is given as 25 kilonewton into 10 to the power 3 Newton and E is given as 500 mm. Now what will be the area of this weld? So suppose size of the weld is S, then throat thickness of the weld is T. Okay, so T is equal to 0.707 into S, as we have seen in the many questions before. So what will be the area at throat, because that area will be minimum at throat and maximum stress will be developed at that point. Okay, because suppose this is a fillet, then this is S, this is S, then this is T. So this is minimum width. Okay, minimum width of weld. So at this plane maximum stress will be felt. Okay, or okay, so what will be area? Area will be equal to, see, this is thickness is T, so this is T, this is also T, this is T, this is T. Okay, all the thicknesses are T. So 100 area will be equal to, see, this area plus this area. There are 4 areas, 1, 2, 3 and 4. Okay, so these two are same, opposite areas are same. So A is equal to T thickness into 2 into B plus 2 into L, because it will be B into L, sorry, B into T. This is B into T plus B into T plus L into T plus L into T. Okay, so this is like this. Now it will be T is 0.707 S into 2B plus 2L, which will be equal to 0.707 S into 2, width is 150, sorry, B is 100 plus 2 into 150, so it will be equal to 353.5 S square. So this is area. So direct shear stress tau will be equal to load upon area, which will be equal to 25 into 10 to the power 3 divided by 353.5 S. So it will be equal to 70.72 divided by S Newton per square. Okay, similarly, what is the moment? Bending moment. So bending moment will be P into E, force into distance. So M will be P into E, which is equal to 25 kilonewton into 500 mm. so it will be equal to 12.5 into 10 to the power 6 Newton mm. So this is bending moment. Now we have a formula, m upon I is equal to sigma upon y for bending in beams. So m will be equal to sigma I upon y. So I upon y is called section modulus z. So m is equal to sigma into z. So what will be the z for this section? You can use direct formula. Z is equal to T into BL plus B square by 3. Okay. Sorry, T into H into L plus H square by 3. Because I am taking B this and H is equal to 150, so it will be equal to 0.707 S, which is equal to T into this H is 150 into L is 100. Sorry, this is B not L. H into B into 100 plus 150 square divided by 3. Okay, so it will be, if we will calculate, it will get this value. Now sigma is equal to sigma bending is equal to bending stress is equal to m by z. So it will be 12.5 into 10 to the power 6 divided by this value 15907.5 S. So it will become 785.8 divided by S Newton per mm square. Now what will be the maximum shear stress? Tau max from principal stresses theory. It will be equal to half into sigma b square plus 4 tau square. So it will be equal to half into sigma b is bending stress square plus 4 into tau is 70.72 divided by S square. This will be equal to 399.2 divided by S. Okay, and tau maximum is 75 given in the question. It will be equal to 399.2 divided by S. So from here S will be equal to 399.2 divided by 75. So it will be equal to 5.32 mm. So this is the size of the weld, okay, or leg of the weld. Okay, so I hope you understood this problem, and if you have any doubt then you can ask in the comment section, and thank you for watching.